Hello, everyone. This is Security is Not the Future. Welcome to my talk. It's basically a brief introduction about web application security and also a kind of friendly reminder of why all of us, even the front-end developers, are part of the security process. So my name is Ignacio Anaya. I am from Argentina. That is my Twitter handle, so you can reach me there if you have questions or if you want to talk about security or whatever. I am working as lead open source engineer at Checkly. Checkly is a company that provides delightful monitoring for web developers for DevOps and for the modern stack. So you can take a look later. I am also ambassador of OutZero, and I am streaming in Twitch, mostly in Spanish, but maybe if you speak Spanish and you want to go around, just take a look to my Twitch channel. So let's start answering, or let me start with this question. So it's our duty as front-end developers take care about the security process, and the answer is yes. The short answer is yes, because security is a teamwork. Front-ends, back-enders, QA, DevOps, even the clients and the users. So all in conjunction, we should take care about security. And you can raise your hands. I am going to say a question. Of course, I cannot see you, but how many of you have been hacked? I can answer that for you. I love quotes. I will put some quotes in this talk, but this is my favorite. There are two types of companies: those that have been hacked and those who don't know that they have been hacked. So it's probably that most of you, especially the big companies or the ones that are working in big companies, have been hacked, and maybe you don't even notice that. And the most important thing in this talk is to understand the problem. We have a problem now. We have a security problem in general in all the companies, in all the products, in all the services. And I will use a recent example to show that. And one of the main characters of the last years, besides the COVID, was a famous video call application. You will probably hear these words a lot during the last year, and maybe sadly we will keep hearing that. But yeah, it was one of the most important players. I'm talking about Zoom. And Zoom, it's a company that suffered a lot of hacks or vulnerabilities during the latest time. Data breaches, security fixes in different kind of operating systems, a lot of things there. And then we have like these releases of the new version of Zoom that they release or they fix the security issues. They improve their security. They release security as a feature, actually. And the thing is that Zoom was not a new application. They were in the market like for the 10 years. So Zoom was probably always an insecure application, or they actually always had these kind of vulnerabilities. The problem is that they became more popular. They became in the spotlight. All people started using it because of the pandemic. So it's like they became massive and they became the point of attractions to hackers. And that is the lesson here. We cannot wait to that moment. We need to start addressing security before of that. But Zoom is not the only one. We can see the biggest companies in the world that have suffered attacks, like Apple, Microsoft, Google, Twitter, a lot of them. And if you take a look to the numbers, we have more than 11 billions of records that were stolen. And these numbers increase year by year. Breaches from 2017 have been duplicated in 2020. So the worst part is that we don't even notice those breaches sometimes. We don't even notice that we had the vulnerabilities or we suffered the attack. And this is an interesting chart. You can take a look later to the link. And it's basically, it shows the history of breaches in the modern internet. And you can see how those breaches increase year by year. If we go to the latest year, you can actually see the biggest players in the industry around there. So it's a problem that it's really hard to solve and will involve all of us, no matter how big or small are we in this scenario. And why or how is that possible? And what I think is that it's possible because we are part of an uneven competition. What I mean here is that we as developers, programmers, or companies needs to compete with the hackers or with the malicious users. And it's uneven because we need to do everything right at every moment. And a hacker just need one chance, just in something that we made, one mistake that we made, some thing that we didn't take care, something that we didn't notice, and that thing could be enough to tackle down our entire system. And sadly, we suffer damage in each hack, in each data breach in each kind of vulnerability we suffer. And each of those breaches or hacks are basically loss of money. We suffer consequences in stocks, in money, in penalties, in higher security teams to fix our stuff. We could even have lawsuits if we lose useful or sensitive information of our users. But the most important thing, at least for me, that I am a developer, is that we lose the trust. We lose the trust of our users. We are unable to take care of their information, of their security. They trust us, and we are not able to respond in the proper way. And we need to start thinking, if we want to take care of that, that we need to be ready for a long-term solution. There is not short-term solution. And this long-term solution starts with a culture, actually with the security culture. And security culture is basically values and knowledge that we need to acquire in our team, in our company. And that it's using or spending time in training, spending or writing politics. I mean, how are we going to move forward regarding permissions, regarding authorization, regarding our authentication system? Everything should be written in politics. And with, of course, need time. We need to invest time, but what is most important for all of this, we need to invest money. And this is the second quote of the day. If we spend more on coffee than on IT security, you will be hacked. What's more, you deserve to be hacked. And this is right. Richard Clark, it's right on this. Or there are a lot of companies spending more money in trivial stuff, than spending real money in web security, on making the whole system or software as secure as possible to go on production. So the short answer is that we need to invest. You could invest now, you could invest later, but sooner or later you have to invest. You have the chance to do it now, to start taking care now, and to avoid a lot of consequences in the future. You could do it later when it's too late and you have to pay more money, you have to recover your reputation and lose the trust of your users. That is on you. And the other important thing that we need in this long-term way that we have, it's start thinking using a systematic thinking. So we used to take care of software of different pieces working together, like the security, like the user experience, like the accessibility. And it's like we consider those parts or those stuff as features in our development process. And those things are not features, they are just part of the software. We need to start thinking the software with all of those concepts from the beginning, from moment zero. It's like we need to use or to incorporate those stuff as a default behavior anytime we start writing code. One of the main things that we deal anytime we talk about web security are vulnerabilities. There, every small thing that we connect to the internet has the power to tackle down the world's biggest site. So vulnerabilities are everywhere. Yeah, it's like this philosopher said, vulnerabilities are like ants, they are everywhere. And that's true. For instance, we have this case that it's called Heartbleed. Heartbleed was an SSL bug that was introduced around 2011. But was discovered in 2014 and was present in most of the biggest cloud providers like DigitalOcean, AWS, Azure, and probably more. And was a really serious bug that let you read memory data from the memory server and basically steal it and impersonate users. Was really serious and was something that was there for at least 3 years. We don't know how much people, took advantage of this, but was there at least for 3 years. And Heartbleed is not the only one. Those here are popular bugs related to SSL that were present in NPM packages around the latest years. And the reason that vulnerabilities are everywhere and we need to deal with them, it's because the web is complex. I mean, if we are creating web applications, we are dealing with the web, and the web is complex. It's complex. We have a lot of protocols and services. We have HTTPS, WebSockets, DNS, TCP, FTP, a lot of protocols and stuff there. A lot of lines or thousands of lines of codes there that could have vulnerabilities. But also because the browsers are complex too. We used to have HTML, CSS, and JavaScript, but it's like we now have more complicated stuff like geolocation, multimedia, fetch, web storage, things that bring us a lot of power in terms of features or things that we can create, but also responsibilities to take care. And it's not an easy problem, I know that, but at least we understand how it works, how or which are the consequences now, or which are the things that we need to start taking care. So we can start talking about the solution, right? Or at least try to understand the solution for this big problem. And the first and most important thing is that there is no perfect solution. I think if someone has enough resources and time, they will probably hack us because it's possible. But sometimes security is about mitigating risk. So we can be ready for that. We can control the damage. We can sandbox everything. If someone is trying to enter to our house, it depends on the things that he can install from our house. So as I said, security, it's more to mitigate risk than to make it our system impenetrable. So we have to change the tape, right? Security is not a nice to have. That is clear, right? We cannot pray for our apps to not be hacked. We cannot wait to be lucky. We just start thinking about security as a default behavior. You have to design your app secure from the ground up. Security should be part of the process, not something that you check before going to production or you audit before going to production. And you need to understand your code, know your devs, have security team or have a security culture, test, stay updated, a lot of things that we can discuss a little bit later. And always assume the worst. Always assume that someone could steal your information, could access your system, and that your data could be compromised. So this is the best advice I have to start learning or to start taking care about the best practices in terms of security. If you are ready for the worst, you will know what to do and how to protect your data and your system. So, Rian, always assume the worst. Security could not be by obscurity. Security could not be by ignorance. As I said, security should be by default. And your app is your best friend. Yeah? You have to know the functionality, the intended behavior, the inputs, the outputs, all the processes inside. So that's the only way how that you can understand how to manage and prevent any security issue in the future. So you have a lot of input vectors. Input vectors are all the possible ways that your application could introduce or receive data. So you have to know all of them. Those input vectors could be query string, URL path, request body, cookies, files, emails, web hooks, web sockets, a lot of things around the internet. So you have to be aware about all of them. And never trust your users. At least in Argentina, we cannot trust politicians. So imagine that the users you have are like politicians, so you never trust them because they can be ignorant, but mostly because they can be malicious. So anything you put there, start thinking that someone will try to hack it or will try to break it. Now that we have that, we have the problem, we have the solution, maybe we can start talking about more technical stuff. And here I have a list of the things that I consider most relevant for front-end developers to start taking care in terms of security that are not 100% advocated to front-end developers, but I think you should be able to address them or at least to inform some of them when something is not working as expected. So the first and most important is use HTTPS. We are in 2021, sorry. There is no reason to avoid using HTTPS. So it's free, it's easy. Let's Encrypt could help us doing it in the proper way. So just always use HTTPS. Then you should always use latest versions, Apache, Node, Nginx, Ubuntu, whatever you're using, use long-term support because it will ensure you that you will get updates and security fixes in the latest months. Dependencies, probably the most important thing to take care because most of the errors came from NPM dependencies or external dependencies. And I really like this. So imagine this galaxy is your app, right? So you have a lot of stars there, but that little star that I put the circle, it's your code, right? Everything in the galaxy is not your code. It's dependencies or code that it's not from you, that someone created, that you didn't test, that you didn't create, that you didn't audit. So another quote from this philosopher, your code is not your code, but their bugs are your bugs. So we inherit vulnerabilities. If someone that it's creating an NPM dependency puts has some bug there, we are inheriting that. And there is this common case about ESLint scope. You probably hear about that, but was basically a library hijack some years ago, where the hacker tried to steal npm tokens from the repositories. Most of the people didn't know that they were using this library because it's part of the ESLint ecosystem, right? We are not strictly requesting this library, but any user or any library that's using ESLint, it's probably using that in behalf. So, as I said, most of the things that we have, we don't even notice that we have it. That it's so important that we use things like dependent bot or Sting to audit our dependencies and to have a periodic system verification where we can get updated about problems, security fixes, or whatever. Then another recommendation is to use front-end frameworks. Sorry, my bad. So they are tested, they are audited, they encode, they escape, they take care of most of the things by default that you need to take care in front-end development. So using some of them or using them, it's probably a good way to mitigate most of the risk, especially the XXS risk, or at least to be aware that something it's happening and that you need to take care, because when a vulnerability is found in a framework, most of us will get notice. Let's talk now about SQL or NoSQL injection, SQL, NoSQL. So this is kind of the oldest attack, but it's still relevant. There is actually a recent case in the Stanford University, and it's when someone attempts to introduce malicious code in our database, probably using database queries. So there is this myth about a car trying to hack a transit camera. I don't know if it's real, but as I said, we have this Stanford University case that was really recent. I think was from last year, that it caused like 70K grants of loss for the university, where they suffer a SQL or NoSQL injection attack. That it's like the most common scenario. To prevent that, you should always use server-side validation. Client-side validation is great, it's awesome, but it's also user experience. It's only user experience. It's not security. So if you really need to validate data, always in the server, do it in the client, because it's a great usability tip, but do not rely on that. You always need to sanitize your queries, clean and try to make them what you expect. Use ORMs or ODMs. They try to mitigate most of these security issues. And let's talk now about XSS. So XSS, it's cross-site scripting. It's the most popular thing that we can find in the browser in terms of security issues. And it's where we try to run malicious code in user browser. It could let users to access a storage, cookie, or make web redirection, access to sensitive data. There are different kind of XSS attacks, reflected, store, DOM base. They are easy to detect, but they could be massive, so we need to take care of that. There is also a kind of variation called CSRF, that it's more scope, but it's more dangerous and it's more hard to detect. And the most common case, it's a blog where we try to put JavaScript in a blog comment, and that comment, it's not being validated, it goes to a server, it's stored in the database. So anytime now that the browser renders that page with the blog post and that comment, the comment will load JavaScript, and that JavaScript will be rendered by the browser and could do any malicious thing the hacker wants. And this happened to Facebook some years ago, actually, to Mark Zuckerberg wall or news feed in Facebook. So if it happened to Mark, it could probably happen to everyone. Some tips to prevent that. Especially server-side validation, always. Sanitize inputs, the same with the queries, but now with the user inputs. HTML encoding, as I said, most of the JavaScript frameworks are already doing that. So use the frameworks. Most important, use HTTP secure response headers. You have the list here of all of them. The most important one is content security policy. You have a link if you want to dive later on those, but things like Helmet, that it's an Express plugin, already take care of that. So you will probably find some tools or libraries that handle that for you, and you don't need to manually introduce them. Denial of service, DOS or DDoS, are basically really dangerous because it could make your whole system inaccessible. You can allow a user crash it, saturate it, overload it, whatever, and big companies already suffered that, like AWS, GitHub, Cloudflare. They all of them suffered this kind of attacks before. So it's really dangerous. There is also this popular Operation Payback that was like part of an anonymous vendetta to companies that were blocking WikiLeaks or the Pirate Bay before. So there are serious cases around this, and there are things that we need to do in order to prevent them. So we can implement rate limiting, so avoid that a user could request X amount of endpoints or resources from our servers in a set amount of time. Of course, have a proper error handling, use explicit crashes. We cannot let our system crash anytime we have a validation error, because a crash could allow a malicious user to use that endpoint or that functionality to put our system asleep. Take care about the regs. Sometimes we use exponential regs that needs a lot of time to complete or to match. So take care of the regs. Do not use really complex regs or try to test them because sometimes we didn't notice, but the DOS attacks could become because of a reg that could never end. And you can also implement IP binding. Basically, if you are noticing someone is trying to hack you, you can just ban that IP. Let's talk about sessions and tokens. So it's basically the way that we need to prevent or best practices to prevent users impersonate or steal sensitive data. Our sessions and tokens should be expirables. We could implement allow list or deny list. We only allow those tokens, we deny all of those tokens. You can use patterns like OAuth or OpenID. They are really good practices in terms of security. So they are there, they are free, you can use them. Or you can use on single sign-on. Sometimes sessions and tokens are really hard, so you can trust in single sign-on services like Auth0. So just delegate security if you are not able, not security, sorry, just delegate authentication if you're not able to take care of that. Then passwords, we don't handle them correctly. Of course, there is important to not store them in text base, always encrypt, or actually hash them, not encrypt, and just start thinking about security policies. You can check here in this page how much it will take to crack a password, depending the year and depending the amount of characters, and it's really fast. So some tips you can use hash with the salt. Bcrypt is like the standard. There are all kind of algorithms, but this is like the default. Use passwords or strong passwords. Enforce your users to use them. Teach your users why you should use them, and with good entropy, always try to activate or offer the possibility to multi-factor authentication or two-factor authentication. And take a look to this site. This is called Have I Been Pwned? It's a website created by Troy Hunt, a security guru, and where you can check if your email address or if your password have been pwned before. I think Chrome and Firefox are offering this kind of service just embed in their browsers. But basically, you could put your email there, your password there, and check how many times it was breached in a hack before. This is a great service. And the good thing is that they have a public API and they have a public DB where you can get and implement that or use that as part of your infrastructure or software. So anytime a user is trying to set a password or a combination between email and password, you can check there if the password was compromised before. That's a good improvement. I mean, a little bit more difficult as the default behavior, but I think it's something really useful. Let's talk now about passwords and secrets, but the passwords, I mean the password for GitHub, for AWS, for the things that you use as a developer. CIs, dev tools, cloud providers, key token secrets. Sometimes developers or people working in the software or employees are part or are like the input vector to the system. It's really important to take care responsibly of this information. You can use black box. It's the kind of GitHub repository encrypted using GPG to store information. Do not put your secrets in your repository. Use Keybase or some similar tool to share sensitive data among the team. Use GPG for emails or for encryptation of sensitive data. Password manager, secret manager of AWS, MFA, always try to put MFA in all of your accounts. This is really important in general. I mean, we should take care about those credentials, secrets, tokens that could open the door to the AWS account. This is really serious. So one of the latest things, cookies. There are two things to take care of this. Cookie flags, we should always use these flags, HTTP only, secure, and send site. but we should also scope our cookies with domain, path, and an expire date. Those are best practices in order to make our cookies as reliable as possible. Then about logging and monitoring, I consider this really important because it's the only way that we can see what is going on or audit what passed before, or actually get information if we suffer an attack. There are a lot of tools in order to do that. I will mention some of them: Datadog and New Relic for monitoring, Sentry and Bugsnag for error handling, Papertrail Logly for logs, to have a nice UI for the logs. And for status, you can take a look to Checkly, of course, or Pingdom, some other alternative. And I think this is probably the last thing. What about sensitive data? What should we do with sensitive data? Well, you just don't need to expose them, never. Encrypt on rest, don't break users' trust, don't store it in the browser, always use SSL, disable caching of sensitive forms. Basically, do not expose sensitive data. This is really important. So far, so good. I mean, we are not experts. I actually am not a security expert, but I think we have enough to start taking care of security, to start learning, or to, it's like the tip of the iceberg. So we just need to dive in the rest of the iceberg. A good place to start is the OWASP Top 10 project. It's basically OWASP. It's an organization that it's trying to take care of all the security ecosystem. And this top 10, it's like the top 10 of the most popular vulnerabilities in the world. They update that year by year. Most of the top 10 vulnerabilities we already discussed in the talk, but you can take a look to other things that are more related to infrastructure or to backend. Then there is this nice project also backed by OWASP that is called WebGoat. I really like it. It's like a web application insecure by default that you can use it to train yourself and to learn about security issues, security best practices. It's really easy to start using it. You can just pull a Docker image and you can start learning about security using a real application. And to take away I always like to do these takeaways in my talks. So I think that the first thing is that we need to invest and train ourselves in security. We need to know our apps. We need to know all the possible ways that they can be hacked, and we need to assume the worst in case that happens. And of course, apply the good practices or tips that I suggested before, and use that as the starter for keep growing and learning in security and incorporating security in your teams or your companies. Code review, audits, pen testing, etc. Things that you can do later in order to achieve a security culture. And remember that we are as secure as our weakest link. So we need to find that weakest link, and we need to make it as secure as possible in order to increase our strengthness. Start taking care of security. It's not something that we can delegate. It's not the problem of someone else. It's not just infrastructure, DevOps, or a company problem. It's a problem of all of us. And most important thing, try to change your mindset. Start using a systemic thinking for software. Take care of security, accessibility, user experience, performance from the ground up, from moment zero. Those are not features, are just part of the development process. So that's it. Thanks a lot for coming to my talk. And if you have questions, if you have suggestions or feedback or whatever, you can reach me in Twitter. Those are my social networks. And thank you very much for hearing me.